All right. The next set of um, patterns that we have with sequences that are very common are um, what are called geometric. Oops, wrong thing there. Sorry about that. All right, are geometric. Now, geometric sequences are also very common, all right, and do also have a concurrent, all right, a partner that's in the function realm, an algebra realm. Now, when you talk about geometric sequences have what is referred to as a common ratio. Common ratio. Now, a common ratio is found a lot in geometry, and what this is usually referred to as R. All right, and when you have this common ratio, what's happening is that you're multiplying the ratio repeatedly. Okay, you're multiplying a number repeatedly. Okay, so for example, when we have this, and here's an example of a geometric sequence. We have our first term, we have a second term, we have a third term, fourth term, and so on and so forth. And we're looking for the nth term, all right, the nth term. Okay, so we're looking for an nth term here, okay, and we're looking for this number pattern and put it in terms of n. Now, if you notice this right here, we see that in order to find the second term, it appears that we are multiplying by 1/2. If we could look at it that way, oops, not 1/4, 1/2. 1/2. It appears to find the third term we are multiplying by 1/2 again, because we got 3 over 1/4. And then to find the fourth term, it appears that we are multiplying by 1/2 again. So if we write this out and we look at the recursive model, all right, the first term we know is 3. The second term, we take the first term, which is 3, and multiply that by 1/2. And I'm going to put that in the different order. So we're going to have 1/2, all right, times the first term. To find the third term, we take the second term, and we multiply that by 1/2 again. And what we get is 3/4. To find the fourth term, we take the third term and also multiply that by 1/2. And so you can see the pattern is that the recursive model is that if I start with the first term being 3, the nth term, or the next term, is always going to be the previous term, n minus 1, that's the previous term, just so you know, right? And we're multiplying that previous term by 1/2. And we'll put the 1/2 in front, make that nice and pretty. All right, 1/2, we have a sub n minus 1. And so what we have is we're multiplying the same thing over and over again. Well, when you multiply a value repeatedly, you might come to acknowledge that, hey, that is what's known as our time in algebra, as exponential, and would form an exponential model. Exponential models have a common base, because if you're familiar, y equals, we have our initial value of a, and then we go a sub 0 or something like that, and we have b to the x power. All right, that is a basic exponential. We have a base to some sort of x. Well, the key thing is identifying what that base is. Well, the base in this case is actually our common ratio. So this right here, which is the base, the number that has been repeatedly being multiplied together, is what is known as the common ratio. The common ratio. Our x value is, once again, n. All right, so if I write all this stuff out again, all right, our x value is n, and our y value is a sub n. So if I write out this pattern, what I have then is, I guess, our nth term, if I wanted to find out an explicit definition, the nth term would be, well, our initial term, and that would be our ratio, which is 1/2 to the n power. Now, to figure out what a sub 0 is, we have to go in the previous direction. So one thing we can do is we can plug in a point to figure out a sub 0, all right, our initial value. And when we have this right here, a sub 0, and I'll plug in a point, which is our first term. So our first term, I'll have 3, and I'll have a sub 0, I'll have 1/2, and I'll plug in a 1. So I'm plugging in this point right here. 1, 3 right there. Okay, so 3 is my a sub 1, so I plug that in there. All right, so I plugged in a sub 1 equaling 3, right, into that value. And when I can solve for a sub 0, and a sub 0 is going to equal 6. It's going to go 6. So I find my final equation is going to equal, I'll write this out, a sub n equals 6 times 1/2 to the n power. Just to test it out, let's put in 2. We have 4. All right. So a sub 2 is, we'll just test this, 6 times 1/2 to the 2nd power. That'd be 1/4 then, times 6, and which turns to be 3/2. And what do you know? By golly, it worked out. All right. So we can test out always test out your models when you figure them out. So that's what we have. So once again, we can come out and write out a general equation of a geometric sequence. So from this model, a geometric sequence is a sub n, the first term, all right, times the ratio to the n power. Where once again, r is the base, or the thing that you're multiplying repeatedly, common ratio, n is n, a sub 0 is your initial value. Now, you can also write this, you see in a lot of textbooks, is they have this. They switch it around, and they write the first value, okay, the first term, to the r to n minus 1, okay? And how they get that? Well, using a little bit of algebra, okay, you can confirm that this works out, and then just to verify that both those are okay. All right, we can take this, a sub 1, r to the n, and then we have basically r to the negative first power, which is a over r, or a to the first over r, times r to the n. Well, when we divide by r, what we're doing is going in reverse. So actually this right here, first power over the ratio, we actually are getting a sub 0. Okay, a sub 0. So that's how that is also going to be true. All right, that both of these will work out. Traditionally, just to let you know, that this is a very common way of using it because many times you're not given the initial term, all right, you're given always the first term. So a sub 1 to r to the n minus 1 is used a lot, but either one are fine and great. Okay, so that is a geometric sequence. It's exponential. Okay, we use an exponential model to help us find it. It has a common ratio. And recursively, we're multiplying each time. So that's different than arithmetic, when arithmetic has a common difference, where we're adding. So geometric, multiply, arithmetic, add. All right, and those, all right, this is the final of 2 main common sequences that we'll be discussing. All right, so I'm going to have some more examples in the next tutorials. So maybe check those out.